Another relevant control is about missing data. Despite our best efforts to obtain complete answers, very likely we will have some missing. This may be more or less critical depending on the analysis we want to run, but surely it is something we need to be aware of. What can we do if we have missing data? We have at least 4 ways for managing them. Delete or simply exclude from the analysis the observations that contain missing data, in particular if there are several. If our sample is large enough and the observations with missing data are distributed across the various classes, we can do this without introducing any bias. Listwise deletion means deleting the entire observation, so losing also the available data. Pairwise deletion means considering all and only the available data in each analysis, without discarding the whole observation. Delete the variables with a higher proportion of missing data. If they are not crucial in our model, in this way we don't affect the sample size. Replace the missing data with the mean or median or mode. This is actually arbitrary and may introduce some bias in the data, so needs to be considered carefully in its implications. Predict the missing data by using an algorithm that uses the available data to predict the missing ones, according to the known characteristics of the observations with missing values. For example, if we miss the information on the sales for one observation, but we know the information on the number of employees, and we find out that there is a high correlation between the two, we can predict the sales according to the number of employees. Of course, this does not provide any new information, but usually a better estimate than the mean. Another control that is usually suggested is the check for common method bias. As we have seen in previous lectures, common method bias means that data show higher correlations than reality, due to the use of a single measurement method, social desirability, and so on. Despite our efforts in preventing this problem with the design and administration of the survey, we need to make sure that this problem is not affecting our data. The most common way of doing this is the so-called Harman's single factor test, which consists in testing whether the majority of the variance of all variables in our survey can be explained by a single latent factor. If this is true, it means that common method bias is indeed present, since all variables are highly correlated with each other. If not, we can conclude that this is not a problem. Although very common, this method has been criticized to be not sufficiently reliable, and more sophisticated methods have been proposed, such as those based on partial correlations, which are, however, beyond the scope of this course. Now that we have finished preparing our data, we can finally proceed with data analysis.